Hello, we are Group 7, and this is our IE 441 Capstone project. The company that we have worked with is John Deere Seeding in Moline, and our team members are Daniela, Isaac, Alan, and Tyler. John Deere Seeding is one of the smallest factories that John Deere has. This group makes about 10 different products with about 250 different order options for customization. Since this company is small, congestion and organization on the floor has been a really big problem and something that we focused on during our project. Our main objective for this project is to increase the floor space available in the bay build area. Along with increasing floor space, we will be focusing on improving the flow of the materials from the bay build area to the main assembly line and trying to reduce the walking time of the operators by 25%. All of this will be achieved by creating the optimal floor layout.
Within our current state analysis for this project, we focused on four main topics of study. The first being floor space and area usage, operator movement, cart design, and the amount of vertical space used. With the methodology of how we conducted this analysis, we first validated what we saw in the AutoCAD drawing, what was seen in the actual state during our on-site visits. We created many spaghetti diagrams for operator and cart movements. We measured the distances of these movements, and then we broke down analysis of how the entire floor space was used by its specific use cases. From this analysis, we were able to find some main results and findings, which included some safety concerns due to congestion in certain areas, insufficient and inefficient usage of the space and how it stores parts, and excessive operator movement between and around work centers. From this, we were able to come up with some potential changes to implement in the FSD and quantify some return on investment and impacts we could see from these changes. To combat the challenge of floor space area usage, the solution approach we used was creating 3 separate floor layout revision options to give to John Deere. The first option just reorganized items that we saw in the current state analysis. The second option consolidated the storage of certain low usage parts on racks and dollies and removed some of these racks and dollies from spaces where they were no longer needed. And the third option implemented an autonomous self-picking storage unit. Within each of these layouts, we reorganized the arrangement of equipment, dollies, and carts within work centers to free up a total of 589 square feet of floor space. We also relocated specific work centers to new spaces within Bay Build to more efficiently use the space as a whole. And after discussions with some of the stakeholders at John Deere, we decided that Layout 2 was the most optimal option to move forward with.
Through observation of the bay build area, our team was able to find ways to move work centers around so that we could reduce the walking distance for an operator cycling between 3 specific work centers. Our goal was to reduce the total walking distance by at least 25%. Our team also found ways to bring required materials into the work centers in which they were needed. We did this by restructuring the layout to open up space in these work centers. This also helped reduce the walking distance for these operators. On the right is a table that shows the current route taken for the operators, the walking distance before restructuring the layout in the CSA column, the walking distance after restructuring the FSD column, and the percent reduction. Our team created new cart designs after observing excessive movement to the main line with material handling carts. The objective of our new design was to increase the capacity of the parts that each cart can hold, and so that every cart holds at least double the capacity from the original carts. We also moved the location of the carts in our new layout due to safety concerns, and we think that this can reduce the walking distance by around 1,100 feet per day with the capacity doubled.
Our solution approach on storage and vertical space usage started with researching and receiving quotes and dimensions from 3 companies that have autonomous self-picking shelving units. We then compared quotes, features, and capabilities and created a layout alternative that incorporated our recommended shelving units. For our economic and qualitative impact, we calculated that 580 square feet of space is valued at $60,000 for construction costs. With revenue per square foot valued at $20, we estimate savings of $11,780 per year. We calculated the reduction in operator movement that will lead to a cost savings of $13,250 per year. We improved safety by moving material handling carts and reducing clutter, and increased time for value-added work by the operators. Thank you for listening to our team's capstone final presentation.